Hey, what's up, pre-calc students? In this video, we're just going to go over the first two problems on this note sheet. So we're going to try to solve some polynomial inequalities by using a graph. So in this video, I will be using three colors. So it might help if you guys grab three different colors. It'll help you see things a little better. So let's get started. So here is a polynomial function. We're going to find the zeros and sketch the graph. So we did this in the past. We're just going to set that function equal to 0. And we're going to try to solve by factoring. So the GCF would just be x. Take that out. And now we'll just break down that trinomial. So we'll keep the x there. Set up our two parentheses. Need an x here and x here. And I truly believe that a -5 and a +3 will get the job done. So now we're going to set each factor equal to 0. So for this first one, we'll just get x equals 0. Here we'll get x equals 5. And here we'll get x equals -3. Now, since each factor occurs one time, that means the zeros each have a multiplicity of 1. And if we go back to our unfactored form, we see that the leading term has an odd power and a positive coefficient. So that tells me when I sketch, the ends of my graph should be doing that. So I'm going to use black to sketch the graph. I'll save the red and blue for something else. So first thing we're going to do is just mark off those 3 zeros. And then since each one has a multiplicity of 1, the graph will just cross through each of them. So coming in from the bottom, we'll come up, we'll hit this guy. We're going to have to wrap around, hit the next one, go through, and then come back up and hit that last one. Okay, so now that the graph is complete, we're just going to answer these 3 questions down here. So if I gave you a polynomial equation where it's set equal to 0, well, we could always try to solve that by factoring, and we did that up there. So I'm just going to write the solutions to that in black, and that corresponds to the 3 x-intercepts on the graph. So we'll just say x equals -3, x equals 0, x equals 5. Now the next one's an inequality, so it's saying tell me the values of x for which this function would be less than 0. Well, how does that compare with the graph? So on the graph, we know the function is equal to 0 whenever it hits the x-axis. So you have to imagine the function is less than 0 anytime the graph is under the x-axis. So I'm going to just use blue to highlight that. And what we have to do is just write the answer in interval notation. So it's going to be helpful to maybe just draw a little number line under your graph. This will represent the x-axis. So I'm going to put infinity on that side, -infinity on that side. We're just going to mark off those zeros that we came up with. And we can see that this part of, oops, where'd my screen go? This part of the graph is under the x-axis, and that part of the graph is happening between -infinity and -3. So since it's under the x-axis, I'm just going to write a negative sign, meaning less than 0. Then over here, from x equals 0 out to x equals 5, the graph is under the x-axis, meaning all its y values are negative. So we're going to write negative again. And then that'll help us write the answer to the second question. So whenever it says less than 0, you want to know what values of x make the function come out negative. So we mark that on our number line. So I'm just going to write those 2 intervals here like so. And that would be the official way to write the solution to that inequality. So you have to imagine the last one saying, well, tell me the x values that come out to values higher than 0. So on the graph, that would just be where it's above the x-axis. So we'll use red for that. So on my number line, we'd just be between -3 and 0. So I'll write positive for above the x-axis. Between 5 and infinity, positive again. And then those two intervals would be the solution intervals for that one. Okay, moving on to problem 2. Now this one's already given to us in factored form, so why don't you pause the video, see if you can write the zeros with the correct multiplicities, figure out the end behavior, and sketch the graph. We'll check that out in 1 second. Alrighty, welcome back everybody. Let me move this tissue box out of the way. And like I said, since it was already in factored form, we could just easily go to the zeros. So the first two have multiplicity 1. That last one has multiplicity 2. Wanted to figure out that leading term. So if you remember, we just got to get that highest power on the x. Just make sure we have the correct sign on our coefficient. So it is -x to the 4th. So since the exponent's even and the coefficient's negative, it's going to be pointing down on both ends. All right, so I drew the graph in black, marked off my zeros. We got a cross here, and a bounce there. All right, so now we are all set to finish our problem. I'm going to just draw a number line again. I think that helps us see what's going on a little better. Let's call that infinity, negative infinity. We're going to mark off those zeros. All right. And for the equation, we know the solutions are just the x-intercepts, so we can just write x equals -1, x equals 1, and x equals 3. And as far as the inequalities go, we're just going to color code it again. So for under the x-axis, I'm just going to use blue. And for above the x-axis, I'll use red. So that means my graph is less than 0 when I'm in this interval, and this interval. And then when I'm above the x-axis, these guys will be positive y values. Okay, so number line's all set. Now we're just going to write our solutions down here. So the only difference between this one and the last one, I did put a bar on it. So the bar just means tell me where the function's under the x-axis and also on the x-axis. So when I write that first interval, I'm just going to go from -infinity to -1. We're going to include it. Or then we're going to start with that positive one. Now, I don't have to make two separate intervals out of this because it would be 1 bracket, 3 bracket, and then bracket 3 to infinity. So since we are including that 3, we could just blow right past it and go to infinity. We're all good to go. All right, for this one, a little trickier. So now it says greater than or equal to 0. So we want that interval where the function is above the x-axis. We're going to include those x-intercepts with brackets, so -1 to 1. But since we have the bar on it, we are including the zeros. So we do have to include that 1 0 over there on +3. So let's do a union. And since it's a single number, we could just put it in braces. All right, guys, that is it for this video. We'll talk about the ones on the back next time I see you. Hope you enjoyed. Toodles.